If you looked up tonight and asked, how far must we go to touch another sun? The answer would whisper back, just 4 light years away. Beyond our blue world, a cosmic ocean begins. Vast, silent, eternal. Every star out there is a sun, and every sun might hold another Earth. And somewhere in that silence lies a promise that we're not alone in the dark. And there, hidden among billions of stars, lies our closest neighbor.
Alpha Centauri, a triple star system, 3 suns dancing together across time.
And maybe, just maybe, hiding the first world humanity will ever call home beyond Earth. Sometimes I wonder if someone out there is looking back at us too. I came here to report facts, but found a feeling instead, wonder. Because even across the stars, the human heartbeat echoes the same. Maybe that's what space truly is, not emptiness, but possibility.
This is Lyra Marin, reporting from the edge of everything we know.
And maybe one day, we won't just look up at the stars, we'll walk among them.
4.37 light years. Sounds close, right? But even our fastest ship would need 75,000 years to reach it. Meet Voyager 1, our small traveler still talking to us across space. It has already left the solar system, beyond the sun's invisible border.
Now it sails in darkness, where our sun is just another star.
Light from our sun reaches Earth in just 8 minutes. But to reach the next star, that light travels for over 4 years.
That's the ocean between stars. Wide, quiet, endless.
Long ago, Alpha Centauri was just a dot on our star maps.
Now that dot is a dream, our closest neighbor in the sky.
Every age had explorers.
Ours just looks up instead of out.
We sail with photons now, not with wind.
Each ray of light carries stories from faraway suns. We send our voice across the dark, hoping someone listens. When you see how far that light goes, you realize how small we are. But that's what makes us beautiful. We still dream. Our little machines whisper hope into infinity. Soon, even their light will fade, but the journey won't. Because every ending in space is just another beginning.
A single beam of light can cross billions of miles without stopping.
And maybe, just maybe, someone is waiting at the other end.
For centuries, it was just a name. Now, it's a promise. Alpha Centauri, our first neighbor beyond the sun.
What would it feel like to stand under its light?
Maybe one day, our children will call that sky home.
Until then, we stay connected. Wow. By light, by wonder.
And far behind us, Voyager still sails, carrying our message of hello. A promise written in starlight to keep searching. Just beyond our sun lies the nearest system, a cluster of 3 stars shining together in silence. It's called Alpha Centauri, a triple star system held together by gravity. Alpha Centauri A, the largest and brightest, almost identical to our sun. Its light burns warm and steady, a near twin of the sun we orbit. Beside it, Alpha Centauri B, a smaller orange star, orbiting closely. Together, these two form a binary, locked in a stable orbit that's lasted billions of years. Their gravity binds them, a perfectly balanced cosmic partnership. A little farther out, a faint red dwarf completes the trio. That's Proxima Centauri, the smallest and nearest star to our solar system. It's a red dwarf, cooler than our sun, emitting a faint, steed red light. Its light takes about 4.24 years to reach Earth, our closest interstellar neighbor. And orbiting close to it, a planet that sparked new hope in science. This is Proxima b, an Earth-sized exoplanet discovered in 2016. It lies in the habitable zone, where liquid water could exist. If conditions are right, its sky would glow red, lit by Proxima's faint light. One side always faces the star, constant daylight. The other, endless night. Between them lies a narrow twilight zone, a possible refuge for life. That's where scientists believe water and maybe life might survive. Proxima b orbits every 11 Earth days, incredibly close to its star. No telescope has seen its surface directly yet. But with next-generation observatories, we may soon capture its first light. Alpha Centauri and Proxima, 3 stars bound by gravity, linked across space. They form our nearest stellar neighborhood, a natural target for exploration. Every signal we send, every mission we dream, aims for systems like this. Because in science, connection defines survival, even across stars. 3 stars, 1 system, a destination just over 4 light years away. For astronomers, it's not just the nearest stars. It's not the next frontier. Alpha Centauri, our closest window into the universe beyond. Just 4.2 light years away lies Proxima Centauri, the closest star to our sun. Orbiting that star is Proxima b, a Lyra, an exoplanet similar in size to Earth. It's roughly 1.17 times Earth's mass, placing it in the category of rocky, potentially habitable worlds. But here, daylight isn't blue. The star casts a deep red glow across the surface. A single rotation of the planet might last weeks because Proxima b could be tidally locked. That means one side faces the star in permanent daylight, while the other side remains in endless darkness. The twilight zone between the two could be the most stable region, a place where temperatures balance. Its atmosphere is still uncertain. It might be thin or dense with carbon dioxide. Some models suggest water ice could exist beneath the surface. And where there's water, there's always a question: could there be life? Proxima Centauri is an active red dwarf. Its solar flares are powerful. Radiation bursts could strip away a planet's atmosphere over time. Still, it's a fascinating contrast. One side scorched, one side frozen. If humans ever reached it, survival would depend on creating artificial habitats. Robotic probes could one day confirm what conditions really exist there. If humans ever saw its sunrise, the light would be crimson. The color would differ, but the warmth would still remind us of home. There's evidence Proxima b might have a weak magnetic field, enough to shield it, at least partially. These hidden oceans could hold microbial life, protected from surface radiation. And if it does, there's a chance for subsurface oceans. If one day we step there, the soil will record our first human mark. There would be no wind, no sound, only the silence of a new world. A moment that connects our planet to another across 4 light years. For now, we study it through telescopes and data from observatories around the world. But future missions, like Breakthrough Starshot, aim to send probes there within decades. If they succeed, we could see real images of another Earth-like world. Until then, Proxima b remains a mystery, a dot of data, a promise of discovery. It reminds us how small we are and how far curiosity can reach. Proxima b, our closest exoplanet neighbor, waiting in the crimson dark. To reach Proxima Centauri, we'd need spacecraft faster than anything humanity has ever built. Even our fastest probe, Voyager 1, would take more than 75,000 years to get there. That's longer than the entire span of human civilization. But scientists began to ask, what if we could move at a fraction of light speed? What if light itself could push a spacecraft across the stars? That idea became a real mission concept, Breakthrough Starshot. It proposes sending thousands of ultralight probes, each powered by massive ground-based lasers. Each probe, just a few grams in weight, carries a chip, sensors, and a tiny camera. When those lasers hit the reflective sails, the acceleration could reach 20% the speed of light. That's around 60,000 kilometers every second. At that velocity, Proxima could be within reach in just 20 years. A journey not for astronauts, but for robotic explorers. If successful, the mission could send back the first close-up images of another star system. Just one image of Proxima B would redefine how we see our place in the galaxy. Scientists predict that image could show a rocky surface and perhaps even a thin atmosphere. It would mark the first direct observation of an exoplanet's environment. We've observed thousands of worlds indirectly, but never this close. Such data could help us understand how common Earth-like planets really are. But interstellar space is harsh, full of radiation and micrometeoroids. Because if conditions there are stable, life, even microbial, might exist. Those tiny sails could be torn apart long before reaching their target. Still, researchers continue refining materials and laser technology. Because reaching another star isn't just science, it's a test of imagination. Every prototype, every test brings us one step closer. If a signal ever returns from Proxima, it will have traveled 4 years through the dark. A message across light years, confirming that we touched another world. In that moment, humanity would stand as an interstellar species, at least in spirit. And maybe that's the point, that exploration never really ends. It moves from telescope lenses to dreams, to missions, to stars. Proxima B remains distant, but each beam of light we send brings it closer. Every story begins and ends with home. And our home is that small blue world down there. 4 light years away, our nearest neighbor waits. But silence is where dreams begin. Between us and them lies a sea of silence. From firelight to starlight, we've always looked up. Curiosity is what keeps us alive. We send probes, we send light, and maybe one day, ourselves. Somewhere out there, another sun is rising. Someone will stand there one day, feel the ground of another world beneath their feet, and look back at our pale blue home, whispering just 2 words, "We made it." That moment would mean everything, because every step out there starts from down here. We are bound, not by distance, but by wonder. The universe might be vast, but somehow it feels like it's waiting for us to the nearest star and beyond. Subscribe for more videos like this. We'll see you in the next video. Goodbye.